Okay, my dear students, good morning to all. Today I am coming with a very important topic in atomic structure, that is photoelectric effect, PEE. Right, this is all about energy of light. Light ki particle nature undi ani prove చేసినటువంటి one of the experiment, that is photoelectric effect, and very important for your JEE mains and NEET examinations. Right, don't waste any time. Coming into the chapter, that is photoelectric effect. When a certain frequency of light incident on metal surface, just assume this my hand is a metal surface, a certain frequency of light is strikes on metal surface, that is metal surface also contain atoms. In atoms, electrons are binded to the nucleus, right? Keep that in your mind. That is, a certain frequency of light is incident on the metal surface, electrons are ejected from the nucleus, otherwise metal surface. These ejected electrons are called photoelectrons, and this flow of electrons is nothing but current. Flow of electrons is nothing but what? Current, right? This entire phenomenon is nothing but photoelectric effect. Let me write on the board. When certain frequency of light otherwise incident అనొచ్చు, strikes అనొచ్చు, strikes on metal surface, electrons are ejected. From the surface and flow of electrons is current, and this entire phenomenon is called photoelectric effect. This phenomenon is called photoelectric effect. Dear students, these ejected electrons from the surface are called photoelectrons. Keep this in your mind, right? This is given by Einstein. Okay, Einstein photoelectric effect. Again, I am telling you, when a certain frequency of light strikes on metal surface, electrons are ejected from the surface, and the flow of electrons is current, and this entire phenomenon is called photoelectric effect. And these ejected electrons are called photoelectrons, my dear students. Look at this diagram. That is, this is the metal surface containing number of atoms. Every atom has nucleus. This green part is there in the diagram is nucleus, and those red dots are nothing but electrons around the nucleus. When this light is strikes on the metal surface, those electrons are ejected from the surface and they are going into the flow. That current flow is nothing but what? From light. That entire phenomenon is photoelectric effect. My dear students, look at this. See, H nu, otherwise certain energy. Energy is equal to some work function plus kinetic energy. Let me explain. Incident light energy is E and binding energy is E naught anukundam. Suppose incident energy is greater than E naught, then photoelectric effect will take place. And what do we know? E is equal to H nu. This is the incident energy. That is energy utilized for ejection is E naught. That is I am writing as H nu naught. ఈ ఎనర్జీ ఎక్కువైతేనే ఎజెక్షన్ జరుగుతుంది, అండ్ ఎజెక్షన్ కి సరిపోగా మిగిలిన ఎనర్జీ కైనెటిక్ ఎనర్జీగా కన్వర్ట్ అవుతుంది. దట్ ఈస్ కైనెటిక్ ఎనర్జీ. దట్ ఈస్ ద mathematical expression of photoelectric effect. This phi is nothing but work function. My dear students, ఆ సర్ఫేస్ మీద లైట్ పడ్డప్పుడు ఆ లైట్ బైండింగ్ ఎనర్జీ, ఆ లైట్ ఎనర్జీ బైండింగ్ ఎనర్జీ కన్నా ఎక్కువ ఉంటేనే, ఆ ఇన్సిడెంట్ లైట్ ఎనర్జీ బైండింగ్ ఎనర్జీ కన్నా ఎక్కువ ఉంటేనే ఎజెక్షన్ జరిగి మిగిలిన ఎనర్జీ, ఈ ఎనర్జీ దీనికన్నా ఎక్కువ అని చెప్తున్నాం కదా, మిగిలిన ఎనర్జీ కైనెటిక్ ఎనర్జీగా కన్వర్ట్ అయ్యి ఎలక్ట్రాన్స్ ఫ్లో జరుగుతుంది. దట్ మీన్స్ ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ జరగాలంటే మైండ్ లో పెట్టుకోవాల్సిన మినిమం ఫస్ట్ పాయింట్ ఏంటి అంటే ఇన్సిడెంట్ ఎనర్జీ షుడ్ బి గ్రేటర్ దాన్ బైండింగ్ ఎనర్జీ. ఈ బైండింగ్ ఎనర్జీనే థ్రెషోల్డ్ ఎనర్జీ కూడా అంటారు. ఈ బైండింగ్ ఎనర్జీని ఏమంటారు? థ్రెషోల్డ్ ఎనర్జీ. మినిమం ఎనర్జీ టు బ్రేక్ ద బాండ్, minimum energy to break the bond between nucleus and electron. That is nothing but binding energy or threshold energy, or that is also called as work function. That minimum energy and remaining is converted into kinetic energy. That is kinetic energy is taken as maximum kinetic energy. This is the mathematical form of photoelectric effect. This is incident energy. That is sum of the part of this incident energy is utilized for ejection of electrons, and remaining part of this incident energy is converted into kinetic energy. The minimum energy which is required to break the bond to eject the electron is nothing but minimum work function, and remaining energy is converts into kinetic energy, no? So kinetic energy is taken as maximum. Remaining all energy is converted into kinetic energy, right? Then we can write this as like this: hc by lambda is equal to hc by lambda naught plus kinetic energy, my dear students. Nu is incident frequency, nu naught is threshold frequency. Threshold frequency. Then lambda is incident wavelength. Lambda naught is threshold wavelength. My dear students, అన్ని energies photoelectric effect కు suit అవ్వవు. All energies are not suitable for photoelectric effect. The light with higher frequency only suitable for photoelectric effect. And what we know in VIBGYOR, this is what? Decreasing order of frequency or increasing order of wavelength. Dear students, in this visible light, red is with less frequency, orange is also with less frequency, somewhat yellow is also with less frequency. And ఇంకోటి గుర్తుంచుకోండి, frequency is proportional to energy. Why? What do we have according to Planck's quantum theory? E is equal to h nu. Energy of the photon or energy of the light, energy of the quantum is proportional to frequency of the radiation. That is, frequency ఎక్కువ ఉంటే energy ఎక్కువ ఉంటుంది. That's why higher frequency ఉన్నటువంటి radiations మాత్రమే photoelectric effect ని ఇస్తాయి. That means look at this diagram. That is, here when red light strikes, no photoelectric effect. When blue light strikes, somewhat photoelectric effect is there. And in fact, blue color incident అయినప్పుడు ఎక్కువ photoelectric effect జరుగుతుంది, green color incident అయినప్పుడు కొంచెం తక్కువ photoelectric effect కనబడుతుంది. Keep that in your mind. All the conditions are not suitable for photoelectric effect. The first condition is E greater than E naught, otherwise nu greater than nu naught. This is the one of the condition to exhibit photoelectric effect. Even it is nu is equal to nu naught, ejection only takes place. no photoelectric effect. If nu is less than nu naught, even ejection also not takes place. These two conditions are not suitable for photoelectric effect. This condition is suitable for photoelectric effect. Nu should be greater than nu naught. That means lambda naught should be less than lambda naught. Lambda naught should be greater than lambda because nu and lambda are inversely proportional. Nu and lambda are inversely proportional. This is the condition suitable for photoelectric effect in terms of frequencies, and this is the condition for photoelectric effect in terms of wavelengths. This is all about what? This is all about what? Theory behind photoelectric effect. My dear students, once again I am telling, when a certain frequency ఎందుకన్నామంటే low frequency ఉన్నటువంటి light, low frequency ఉన్న radiations does not show photoelectric effect. That's why I am telling this. When a certain frequency of light strikes on metal surface, electrons are ejected from the metal surface. Those electrons are called photoelectrons, and flow of electrons is current, and this total phenomenon is called photoelectric effect, right? So this is what? This is the incident energy. That incident energy is converted into two forms. Some part of this incident energy is utilized for breaking of the binding, that is nothing but work function. That minimum energy which is required to eject electron, that minimum energy which is required to eject electron is nothing but work function. Remaining everything is converted into kinetic energy. That's it. And this is the game of the formulas. What do we know? E is equal to h nu. This is some part of this energy, so this is taken as h nu naught. What do we know? Nu is equal to c by lambda. I am substituting here. Right? These are the conditions which are suitable for photoelectric effect, and these are not the conditions suitable for photoelectric effect. Okay, we'll do some problems. And one more thing you have to keep in your mind, that is, if nu is greater, very important, very important points what you have to keep in your mind. First point is very important. If nu is greater, kinetic energy is high. అంతే కదా, ఎనర్జీ చాలా ఎక్కువ ఉంది, మినిమం వర్క్ ఫంక్షన్ జరిగాక రిమైనింగ్ ఎనర్జీ చాలా ఎక్కువ ఉంటుంది కాబట్టి కైనెటిక్ ఎనర్జీ ఎక్కువ అవుతుంది. అండ్ సెకండ్ ఇంపార్టెంట్ పాయింట్ ఈస్ ఇంటెన్సిటీ ఈజ్ హై, నెంబర్ ఆఫ్ ఫోటో ఎలక్ట్రాన్స్ ఆర్ మోర్. దట్ మీన్స్ ఇంటెన్సిటీ ఎక్కువ ఉంటేనేమో ఎక్కువ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఎజెక్ట్ అవుతాయి, ఫ్రీక్వెన్సీ ఎక్కువ ఉంటే కైనెటిక్ ఎనర్జీ ఎక్కువ ఉంటుంది. ఫ్రీక్వెన్సీ ఎక్కువ ఉంటే కైనెటిక్ ఎనర్జీ ఎక్కువ ఉంటుంది. వెరీ ఇంపార్టెంట్ పాయింట్స్. If frequency is high, kinetic energy is more. If intensity of light is high, number of ejected electrons is more. Number of ejected electrons are high. Keep these 2 points in your mind. This is all about what? Theory behind photoelectric effect. Note it down. Students, concept complete అయింది. We'll look some questions. Basic level ని స్టార్ట్ చేస్తాం, కొద్దిగా లెవెల్ పెంచుకుంటూ వెళ్దాం, కొన్ని మోడల్స్ కవర్ చేద్దాం. రైట్? The photoelectric emission starts from the surface. See this. The photoelectric emission from the surface starts only when the light incident upon the surface has certain minimum frequency. That is the definition of photoelectric effect, right? That is only the definition of photoelectric effect. Your answer is option C, Chennai. My dear students, certain minimum frequency ఉన్నప్పుడు మాత్రమే photoelectric effect స్టార్ట్ అవుతుంది, ఎమిషన్ స్టార్ట్ అవుతుంది. Here like yellow, orange, red, ఈ ఫ్రీక్వెన్సీస్ photoelectric effect పనికిరావు. వైలెట్, ఇండిగో, బ్లూ, గ్రీన్ ఇవి కొంతవరకు photoelectric effect పనికి వస్తాయి. That means certain frequency is necessary. Note this. Okay, next question. This is somewhat not tricky, not difficult, కొద్దిగా లాజిక్ ఉంటుంది, అందుకనే లేదు. If lambda naught and lambda be the threshold wavelength and wavelength of incident light, the speed of photoelectrons ejected from the metal surface is అని చెప్పి 4 ఎక్స్ప్రెషన్స్ ఇచ్చాడు. చాలా ఈజీ. సో lambda naught is threshold wavelength, and lambda is incident wavelength. And they're asking what? Velocity of the electrons. My dear students, I am taking this expression, that is what? That is hc by lambda is equal to hc by lambda naught plus, in place of Ke I am taking half mv square. We know this from the childhood, right? Kinetic energy is equal to half mv square. Right? We need to get velocity. V we need to get. From this, half mv square is equal to what? This minus this. That is hc by lambda minus hc by lambda naught. Right? What is the LCM of this? Lambda into lambda naught, and hc lambda naught minus hc lambda, that is hc common diste, next half mv square is equal to, I am taking hc common తీసారనుకోండి ఏం మిగులుతుంది? lambda naught minus lambda by lambda into lambda naught. So v square is equal to 2hc by m into lambda naught minus lambda by lambda lambda naught, from which v is equal to square root of 2hc by m into lambda naught minus lambda divided by lambda lambda naught. That's it. Check where the option is there. 2hc by m lambda naught minus lambda divided by lambda lambda naught. Again the option is C, that is Chennai. చాలా చాలా ఈజీ, మీకు ఫార్ములా తెలిస్తే చాలు. ఓకే ఓకే దెన్ నెక్స్ట్ క్వశ్చన్. A light source of wavelength lambda illuminates అన్న strikes అన్న ఒకటే. A light source of wavelength lambda illuminates a metal and ejects photoelectrons with maximum kinetic energy 1 electron volt. Lambda అనే లైట్ ఇన్సిడెంట్ అయినప్పుడు ఇంత కైనటిక్ ఎనర్జీతో 1 electron volt కైనటిక్ ఎనర్జీతో ఎలక్ట్రాన్ ఎజెక్ట్ అయింది, బయటకు వచ్చింది. అనదర్ లైట్ సోర్స్ of wavelength lambda by 3 ejects photoelectron from the same metal surface. అంటే ఏంటి? that is the work function is same. lambda strike అవుతోంది సేమ్ మెటల్ పైన, lambda by 3 స్ట్రైక్ అవుతుంది సేమ్ మెటల్ పైన. అంటే ఏం సేమ్ గా ఉంటుంది? వర్క్ ఫంక్షన్ phi is same in the two cases. Okay, then in the second case, maximum kinetic energy is 4 electron volts. Find the value of work function. They are asking what phi. First of all, I am taking the case 1. What is the case 1? That is hc by lambda. hc by lambda is equal to phi plus 1 electron volt, my dear students. That's it. Phi plus 1 electron volt. What they are giving in this first case? Kinetic energy is 1 electron volt అన్నాడు. In place of kinetic energy, I am taking 1 electron volt. This is equation 1. Okay. Then equation 2. hc by lambda by 3, my dear students, is equal to 5 plus 4 electron volts. This is equation 2. Dear students, look at this. Nothing, ఏమీ చేయలే, మనకు ఫార్ములా తెలుసు, ఇచ్చిన కండిషన్స్ అప్లై చేస్తున్నాం అంతే. దట్స్ ఇట్. సో ఫస్ట్ కేస్ లో వేవ్ లెంత్ ఇన్సిడెంట్ ఇస్ లాంబ్డా, సెకండ్ కేస్ లో వేవ్ లెంత్ ఇన్సిడెంట్ ఇస్ లాంబ్డా బై 3. దట్ మీన్స్ లాంబ్డా బై 3 మీన్స్ దీన్ని ఇంకొంచెం సాల్వ్ చేస్తూ ఈక్వేషన్ 2 ఏమవుతుంది? 3hc by lambda అవుతుంది. దట్ ఈస్ ఫస్ట్ ఈక్వేషన్ ఇస్ వాట్? hc by lambda is equal to 5 plus 1 electron volt. Second equation will be what? 3hc by lambda is equal to 5 plus 4 electron volts. This is equation 1 and this is equation 2. By solving these two equations, my dear students, ఈ hc by lambda value ఇక్కడ substitute చేయండి. What you'll get? 3 into ఈ hc by lambda value ఇక్కడ substitute చేయండి. 5 plus 1 is equal to 5 plus 4. Of course, electron volts and electron volts. 3 5 plus 3 is equal to 5 plus 4. 3 5 minus 5 is equal to 4 minus 3. 2 5 is equal to 1. That implies work function phi is equal to 1 divided by 2, that is 0.5 electron volts. That's it. Very, very, very simple. Okay, my dear students, I am using this formula. First case లో kinetic energy is 1 electron volt అన్నాడు. సెకండ్ కేస్ లో kinetic energy is 4 electron volts అన్నాడు. ఫస్ట్ కేస్ లో lambda is lambda, సెకండ్ కేస్ లో lambda is lambda by 3. అవి సబ్స్టిట్యూట్ చేస్తే కేస్ 1 ఈక్వేషన్ వచ్చింది, కేస్ 2 ఈక్వేషన్ వచ్చింది. By solving 1 and 2 like this, we'll get phi work function is equal to 0.5 electron volts. Again option C Chennai. Note this. Okay, dear students, మూడు ప్రాబ్లమ్స్ చేసాం, మూడు క్వశ్చన్స్ చూసాం. Before going to other question, when lambda is given in angstroms, what is the formula to calculate energy? Energy is nothing but 12400 divided by lambda in angstroms. That is, you get the answer in electron volts per atom. This formula is very, 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 very important, my dear students. Note this down for now. And atomic structure full lesson చెప్పేటప్పుడు ఎలా వచ్చింది ఏంటి మళ్ళీ చెప్తాను. Right, when lambda is given in angstroms, to calculate energy in electron volts, the formula is 12400 by lambda in angstroms. దాన్ని ఒకసారి మైండ్లో ఉంచుకోండి. Okay, dear students, the next question కొద్దిగా tricky. ఇంకో ఫార్ములా ఇంక్లూడ్ అవుతుంది అంతే. Electromagnetic radiation having lambda is equal to 310 angstroms is subjected to a metal sheet having work function 12.8 electron volts. What will be the velocity of photoelectrons having maximum kinetic energy? Maximum kinetic energy. Space సరిపోక max ke అని రాశాను, maximum kinetic energy. First option 0, no emission occurs అంటున్నాడు. Second option 4.352 into 10 power 6 meters per second. Third option 3.09 into 10 power 6 meters per second. And fourth option is 8.72 into 10 power 6 meters per second. This is also very, very easy. Incident energy first we need to find. Incident wavelength is given what? Lambda is equal to 310 angstroms. Incident energy is equal to, that is the formula what I told is 12400 by lambda in angstroms, right? So 12400 divided by lambda in angstroms, 310, that is 40 times. Your answer is 40 electron volts. Incident is 40 electron volts. Work function they are giving what? 12.8 electron volts. They are asking velocity. ఈ ప్లేస్ లో హాఫ్ mv స్క్వేర్ పెట్టుకొని ఫార్ములా వేస్తే సరిపోతుంది. దట్ ఈస్ 40 electron volts is incident is equal to 12.8 electron volts, which is work function, plus kinetic energy. From this, kinetic energy is equal to 40 minus 12.8 electron volts. 40 minus 12.8 is how much? 12.80272, right? That is 27.2 electron volts. My dear students, they're asking what? Velocity in meters per second, right? Zero అయితే కాదు, because incident is greater than threshold, otherwise incident is greater than work function. First option అయితే కాదు, ఈ మూడు ఆప్షన్స్ లో ఏదో ఒకటి అవుతుంది. And what you have to keep in your mind is 1 electron volt is equal to 1.6 into 10 power minus 19 joules. అది ఇక్కడ సబ్స్టిట్యూట్ చేయండి. Then what is Ke? Half mv square is equal to 27.2 into, I am converting that into joules, right? 27.2 into 1.6 into 10 to the power of minus 19. I'm converting this into joules. That is, mass of electron is 9.1 into 10 power minus 31 kgs. V square is equal to, ఇది 2 తో మల్టిప్లై అవుతుంది, 2 into 27.2 into 1.6 into 10 power minus 19 upon divided by mass of electron. Mass of electron is how much? 9.1 into 10 power minus 31 kgs. By substituting all this, and V kada kavalsindi, V is equal to square root of this value, 2 into 27.2 into 1.6 into 10 power minus 19 divided by 9.1 into 10 power minus 31, my dear students. ఇది సాల్వ్ చేస్తే అప్రాక్సిమేట్ గా you'll get option C, I think so. That is S. Option C వస్తుంది. ఆ క్యాలిక్యులేషన్ చేయండి. You'll get option C. Again Chennai 3.09 into 10 power 6 meters per second. జస్ట్ చూసారు కదా, ఫస్ట్ క్వశ్చన్ డెఫినేషన్ బేస్డ్ క్వశ్చన్ చెప్పాను, తర్వాత క్వశ్చన్ జస్ట్ ఈ ఫార్ములాస్ తో చెప్పాను. ఈ క్వశ్చన్ లో ఒక అడిషనల్ ఫార్ములా ఇన్వాల్వ్ అయింది, ఒక కన్వర్షన్ కూడా అవసరం అయింది. 1 electron volt is equal to 1.6 into 10 power minus 19 joules. Very very easy if you have all the formulas and all the conversions in your mind. సో కాన్సెప్ట్ కన్వర్షన్స్ చాలా ఈజీ, ఫార్ములాస్ మైండ్ లో పెట్టుకోవాలి అండ్ క్వశ్చన్ జాగ్రత్తగా చదివి అర్థం చేసుకోవాలి. రైట్, నోట్ ఇట్ డౌన్. Dear student, I am coming into the last question, that is what on the board. The ratio of slopes of kinetic energy maximum, otherwise maximum kinetic energy versus frequency, and V naught versus nu, otherwise frequency curves in photoelectric effect. ఇక్కడ మనకు అన్ని తెలిసినవే, న్యూ అంటే ఫ్రీక్వెన్సీ అని, కే మ్యాక్స్ అంటే మాక్సిమం కైనెటిక్ ఎనర్జీ అని. ఇక్కడ వి నాట్ కొత్తది, దట్ ఈస్ నథింగ్ బట్ స్టార్టింగ్ పొటెన్షియల్. Stopping potential is nothing but potential required, minimum potential to required stop photoelectric effect. So that is nothing but kinetic energy, kinetic energy ప్లేస్ లో ఈవి నాట్ పెడితే సరిపోతుంది. దానికి ఆపోజిట్ లో ఇంత పొటెన్షియల్ యూజ్ చేస్తే దట్ ఈస్ ఫోటోఎలక్ట్రిక్ ఎఫెక్ట్ ఆగిపోతుంది. సో ఇప్పుడు మనకి రెండు ఈక్వేషన్స్ వస్తాయి. ఇదేమో ఇన్ టర్మ్స్ ఆఫ్ స్టాపింగ్ పొటెన్షియల్, దిస్ ఈస్ వాట్ ఇన్ టర్మ్స్ ఆఫ్ నార్మల్ kinetic energy. Right? They're asking slopes of particular curves. Right? First one is Ke max versus nu. This one. Ke max is on y-axis and nu is on z-axis. So Ke is equal to what? Ke is equal to what? H nu minus H nu naught. Y is equal to mx plus c. Of course, here slope 1 is h. Slope 1 is h. Then you take this one, that is what? H nu naught. H nu is equal to H nu naught plus EV naught. My dear students, graph between V naught and nu. V naught and nu. Take this. EV naught is equal to H nu minus H nu naught. ఇక్కడ మీకు y axis మీద ఉండాల్సింది ఓన్లీ V naught. So divide by E on both sides. So V naught is equal to H by E nu minus H by E nu naught. Simple only. So Y is equal to mx plus c. Here slope 2 is h by E, right? Slope 1 is h, slope 2 is h by E. Slope 1 by slope 2, that is the asking. That is what asking in the question. Slope 1 divided by slope 2. Dear students, slope 1 is h, slope 2 is h by E. This becomes E by h. H into E by h. H cancel. Charge on electron is the answer. Right? Option A is your answer. Note it down, my dear students. సో దిస్ ఇస్ ఫైనల్లీ అబౌట్ వాట్ ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ కాన్సెప్ట్ కవర్ చేశాను. అండ్ ఈ చిన్న చిన్న టర్మ్స్ అని మనకు తెలుసు. హెచ్ అంటే ప్లాంక్స్ కాన్స్టెంట్ అని తెలుసు. ఆ టర్మ్స్ ఎక్స్ప్లెయిన్ చేయలేదు. వెల్ ఐఎమ్ టేకింగ్ కాన్సెప్ట్ ఆఫ్ ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్. H is nothing but Planck's constant. That is you have to keep in your mind. Okay, this is what all the models. Okay, that's all for today in this short video. H అనేది Planck's constant. Planck's constant మీ ఆన్సర్ కాదు. వర్క్ ఫంక్షన్ 5 మీ ఆన్సర్ కాదు. H by E మీ ఆన్సర్ కాదు. చార్జ్ అండ్ ఎలక్ట్రాన్. దిస్ ఇస్ వెరీ వెరీ ఈజియెస్ట్ అండ్ ఇంపార్టెంట్ క్వశ్చన్. కర్వ్స్ అనగానే గ్రాఫ్లు గీసుకోవాల్సిన పని లేదు. y is equal to mx plus c ఫార్ములా మార్చుకొని కంపేర్ చేస్తే స్లోప్ వస్తుంది. m is nothing but slope, right? ఓకే, జస్ట్ అండర్స్టాండ్ దిస్ వీడియో. ఎక్కడన్నా అర్థం కాకపోతే మళ్ళీ వెనక్కి వెళ్ళి రివైండ్ చేసుకొని మళ్ళీ వినండి. ఆర్ ఎల్స్ ఎక్కడన్నా నేను తప్పు చెప్పుంటే జస్ట్ కామెంట్ చేయండి. కామెంట్ లో తప్పుని రెక్టిఫై తప్పు ఆ మిస్టేక్ చెప్తే రెక్టిఫై చేసుకుంటా. అండ్ ఆల్ ద ఇంపార్టెంట్ మోడల్స్ ఐ కవర్డ్. మై డియర్ స్టూడెంట్స్, ఇట్లాగా టాపిక్ టు టాపిక్ కాన్సెప్ట్ అండ్ రిలేటెడ్ ఎగ్జాంపుల్స్ అండ్ రిలేటెడ్ జేఈ మోడల్స్ అండ్ నీట్ మోడల్స్ చెప్తూ ఉంటా. ప్లీజ్ సబ్స్క్రైబ్ అండ్ ప్లీజ్ support me to get videos like this. Thank you very much.